Good morning, students. Today we are going to see the forging process. This is the fourth unit. In this fourth unit, we have forging and house wiring. Forging is a process of mechanical working process. In the mechanical working process, metal shape and size is changed into required shape and size by application of heat and mechanical pressure. So as shown in the figure, it was shown where we have one metal piece which is heated above its recrystallization temperature. I will tell what is the recrystallization temperature. Okay, as shown in the figure, the metal piece is heated above recrystallization temperature. When it is heated above recrystallization temperature, it comes in the yellow and white color that you can see in that figure. So when it is heated to that temperature, the metal becomes soft. After that, with the help of hammer blows, we are reducing its shape and size to a required shape and size. So this is called as one kind of forging process, and we are performing this work by heating and application of force. That is why we are calling this one as hot working process. Generally, forging is one kind of mechanical working process. What do you mean by the mechanical working process here is that in the mechanical working process, the components or part size, its size and shape is changed into required shape and size by application of force. So in this mechanical working process, we have different process we have. That is, one is forging process, another one is extrusion process, and other rolling process, rolling, extrusion, forging. Like that, we have different types of mechanical working process. Being CST students, you need not to see all those things. So simple things here we can say. So in this mechanical working process, as I told you before, its shape and size is changed into required shape and size. For suppose, let us assume you take one metal bar having diameter of 20 mm, 20 mm metal bar having diameter of 20 mm. We want to, that is circular cross section, round bar. We want to make it into square piece. So its cross section we want to make into square shape. So there what we are doing, as shown in the figure, the workpiece is, that is round bar, is heated in a furnace. Where we have a furnace, so different kinds of furnaces we have. The furnaces which are where that is using of coal, electric furnace, most of the things we are using the coal. So different kinds of furnaces we have. In that furnaces, the round workpiece is heated above its recrystallization temperature. When it is heated above its recrystallization temperature, so in solid physics, all of you know that you have seen the crystal structure in a metal piece. So where we have crystal structure are grains in all the metals. When the metal is heated, so inside crystals we have, when the metal is heated above its recrystallization temperature, the crystal size will be increased. When the crystal size is increased, it will become soft. When the metal is soft, if you apply the mechanical pressure, easily its shape can be changed. So as I said, our aim here, our requirement is that round workpiece we want to convert it into square shape. So in this process, first we are heating the workpiece in the furnace. After that, at the bottom, see the heated workpiece is held on a metal pot, which we are calling as anvil. ANVAL. Anvil is a ferrous alloy where we have anvil. On the anvil, the heated workpiece is placed. After that, over that mechanical pressure is applied. Then what happens? Its round shape is converted into square shape. So this process is called as forging process. if you perform this process by heating in the furnace, heating the workpiece in the furnace, that is called as hot forging process. Without heating, if you perform that one, it is called as forging process. So say forging is an oldest shaping process used for the producing small articles for which accuracy in the size is not so important. So I said you conversion of round shape into cylinder, that is round bar into square cross section bar, like that. The parts are shaped by heating them in a open fire or hearth by the blacksmithy and shaping them through applying compressive forces using hammer. I told you that heated workpiece is held on the anvil. On that one, that with the help of hammer blows are applied, then its shape and size is changed into required shape and size. This is about the forging process where we have to heat the workpiece. After that mechanical pressure is applied to reduce its shape and size. So to convert its shape and size into required shape and size. I told you cold working process and hot working process. So in the cold working process, the metal piece, see this, the metal piece without heating, we are changing its shape and size. So in the cold working process, so it is hard because when it is not heated, it will not become soft. That is why it needs more mechanical pressure. So it needs more mechanical pressure to convert its shape and size into required shape and size. Not only needing of more mechanical pressure, without heating, if you apply the hammer blows, after some time, cracks will take place. So that is why most of the forgings were going for the hot working process. So forging can be defined as the plastic deformation of metals at elevated temperature into predetermined size or shape using compressive forces exerted through some means of hand hammers, small hammers, die press, and upsetting machine. So here the forging is defined as a plastic deformation. First of all, we should know what is the plastic deformation. So we know if you take a metal, for suppose this one is a see this is a metal piece, let us assume. If you apply the force on the ends, axial force, if you apply the axial forces, if it is if you apply in this direction like this, so we are increasing the length of the turn in this direction. In this direction, if you apply the force, so length of this one is increased. If you release, then it gains its original shape. That is called as within the elastic limit we pull this one. So tensile forces. So applying the forces in this direction is called as tensile forces. Applying the forces toward the center, so toward the center is called as compressive forces. So this one is if you apply the force in this direction, this is called as compressive forces. If you apply the force in this direction, if it is pulled like that, that is called as tensile forces. So if you pull this one, if you apply the force and in this direction outwards, then its length is increased. If you release the forces, it gains its original shape. That is called as elastic deformation. So if you apply the more force and this length of this one is increased by applying the forces, after releasing the forces, if it is not gained its original shape, that is called as plastic deformation. And one more thing I will tell you, circular shape, that is circular bar, when you apply the hammer blows, it is converted into square shape. So like that we applied the hammer blows into to get into square shape. So where the round shape is converted into square shape means where the material transfer where we have, that is flow of material. So when the material is flown from one place to another place, that is square, round is converted into square shape, that is called as flow of metal. That flow of metal is permanent, that is called as plastic deformation. Forging is defined as a plastic deformation of metals at elevated temperature. Elevated temperature is nothing but when it is heated above recrystallization temperature into a predetermined size or shape. After that, compressive forces or tensile forces applied on that one. If you want to convert the shape of that one round shape into square shape, where we are applying the compressive forces by means of hand hammers or small power hammers. Power hammers means that is some kind of machines, die press and upsetting machines. So using that machines, force is applied. So now it consists essentially of changing or altering the shape and section of metal by hammering at a temperature about 980 degrees. This is 980 degrees for the mild steel, at which the metal is entirely plastic and can be easily deformed or shaped under pressure. So what I said just before, I told you, when the metal, simply I will tell the second part. The metal is heated above recrystallization temperature, that is around 980 degrees of Celsius. So where this one is mild steel, the mild steel is having melting point is around say that melting point is around 1600 degrees of Celsius for the mild steel. So around 1000 degrees of Celsius, that is at 980 degrees of Celsius, when it is heated, what happens, that metal inside the crystal size will be increased. This will become soft and easily we can convert its shape and size into required shape and size. So that is about the definition of that one. Say the forging operations can be accomplished by hand or by a machine hammer. So see this one in the starting itself, where we have the figure. This is where this hammer is operated by manually. So in some cases, machine forgings also where we have. So the machine is having one RAM at top. That ram is moved vertically upwards and downwards. When it is moved downwards, the force is just like hammer blows how we are applying. Similarly, where the machine is having a ram is nothing but it is a metal piece having weight of 10 kgs like that. So that is reciprocated vertically downwards and upwards. Then what happens when it is reciprocated downwards? That forging force is applied on that heated workpiece, and then its shape and size is converted into required. So that is called as machine hammer. So hand forging is also known as blacksmithy work, which you are going to perform in your workshop lab, which is commonly employed for production of small articles using the hammers on the heated job. So in our lab also you will take a round workpiece by heating that one. After heating that one with the hammer blows manually you apply, and then its round shape is converted into round cross section. For suppose length of the workpiece say 150 mm. For the 150 mm length, round shape is converted into square shape by applying the hammer blows, and yourselves you will do in that lab also. Okay, so small articles. I said you 150 mm length like that. Say it is a manual control process, even though some machinery such as power hammers can also be sometimes used. Okay, I told you RAM we have, which is reciprocating to convert its shape and size. So forging by machine involve use of forging dies. So where the die is nothing but RAM and is generally employed for mass production of accurate articles. See this one. So forging die, we also call this one as RAM. So RAM is moving vertically upwards and downwards, and it is moving downwards. So hammer blows will be applied. So for suppose round workpiece we want to convert into round piece. We want to convert it into, for suppose, hexagonal shape. So I told you round shape is converted into square. So manually also we can do. In case if you want to convert the shape of that one into hexagonal shape, so then such cases what we are doing, okay, we say 1 minute, 1 second. See this. This is one. See this is one space One minute. This is another phase. The heated workpiece is placed here. If you see, this is the bottom die. We also call this one as phase or die. So here we make the hexagonal shape. This is one kind of shape. For this product, this shape is made. So this we also call this one as top die and bottom die. So here we say top die and bottom die, where you have the heated workpiece. If you want to reduce the diameter of this one, say this is bottom die or bottom phase is fixed on the anvil. Heated workpiece is placed here. When it is placed over that one and apply the hammer blows, its diameter is reduced. Similarly, a round shape converted into square shape by changing the shape of these phases or dies. Similarly, if we have a hexagonal shape here, the round shape can be converted into hexagonal shape. So here this is the bottom one is anvil, this is the top bottom die. This bottom die is fixed, it will not be movable. On this one heated workpiece is placed. I told you we have one ram vertically, the ram is moving upward and downwards. To that ram, this die is placed. This die, top die is connected to a ram. So then when it is moved downwards, say this diameter can be reduced to required diameter. The shape can be converted into square shape. The shape can be converted to hexagonal shape according to the shape of dies we made. Okay. So that is about the forging die. This is called as die. I told you this one has bottom one is bottom space or bottom die. This one is top space or top die. So we also call that one as forging die. What we have seen here. This is used for the machine forging, used for the mass production. In one stroke, the shape is converted into required shape and size. For suppose manually, if the round piece is held between these two dies, you will get this shape. See this part shape you will get. So to convert the round shape into in this shape manually, we need to apply near about 10 hammer blows over that one to convert the shape and size. Okay. So for suppose if it is machine with one stroke, a round workpiece is converted into this shape. That is why in mass production, this machine forging we are going to use, that is very advantageous. Next, let us see the application of the forgings. The producing of crankshafts, railroad equipments, automobiles and trucks, and the components of aeroplane industries which are made by the forging process. Some parts used in the tractor, shipbuilding, cycle industries, railroad components, agricultural machinery, etc. And one small example I will tell you. By forging process, we can make a simple example. We know the hammers, not hammers, wrenches. So open wrench, ring wrench, like that we have those wrenches. That wrenches are used for tightening and loosening of screws and bolts and nuts. To operate the bolts and nuts, we are using wrenches. That wrenches are made by the forging process. So that is simple example for you. In addition to that one, crankshaft, railroad equipments, automobiles and trucks components which are used in that one, and components which are used in the aeroplane also made by the forging process. Okay, these are the applications of forging. Now let us see the what are the tools used in the forging operation and their importance we are going to see now. Say, I told you hot. This one is the hot working process. In the hot working process, so workpiece is heated above recrystallization temperature. We have seen around 980 degrees of 980 degrees of Celsius. That is around 800 to 900 or 1000 degrees of Celsius. Manually operating the heated workpiece is difficult. That is why we need some equipment. So that equipment we are using here called as tongs. See, these tongs are used to hold the work while doing a forging operation. So however manually we cannot hold that one because of heat. That is why that heated workpiece is handled with the help of the tongue. See this one, this tongue is similar to a just like scissor. So it is having handle like this. By operating these two things, so we can close and open the tongue. So using this one, heated workpieces are handled manually from one place to another place, while applying the hammer blows here in this figure. This workpiece is held on the anvil with the help of the tongs. Even in the machine forging also, see this one is machine forging. This workpiece is held by operated, that is handled manually with the help of the tongs. So see this, these are the tongs. So this tongue can be opened and closed with the help of these levers. This is one kind of tool used for handling of heated workpiece. Now let us see the flatter. It is commonly used in the forging shop to give smoothness and accuracy of articles. See, I told you starting of the this one that round workpiece we want to convert it into square cross section. See, this flatter is used. This flatter bottom, it is having a flat face. So heated workpiece. See, if you go to the first one, see the bottom of this hammer is flat. That heated workpiece is placed on the anvil. When it is hammer blows are applied by this one, as the bottom of this one is flat, that round shape is converted into flat shape. Then we will convert the round shape into square cross section. So for that one we are using this kind of flatter. Name itself saying flat, making the top surface flat. So this is flatter like a hammer. These are the swathes or swathes that is made in two halves, bottom swathes or top swathes. We also call them as dies, bottom die or closed die. When these two swathes or dies are closed together, we will get complete shape of that one. You see in the right side figure, these two are swathes or dies. When these two are closed together, we can get the product of at center there is a metal piece of product. Its shape can be made by placing the workpiece between these two dies and applying the force over the top swage or die. So using this swage, it is used for forging work which has to be reduced or finishing. That is, these swages are used for converting the round shape into square or hexagonal shape into square or round. So in different shapes, whatever the shape we have that swage, in that shape that workpiece can be converted by applying the force. That is one kind of tool. This one is fuller. It is used in the forging shop for necking down a forgeable job. It is made in the top and bottom tools as in the case of swages. Say it is used in forging shop for necking down. See this bottom one, necking down a forgeable job. So using this one, okay, we can say this fuller. First of all, say I told you, 20 mm diameter workpiece having length of 120 mm. Sorry, 150 mm. 20 mm diameter workpiece, 20 mm diameter workpiece with 150 mm length. We want to make that one into flat, that is the square cross section or rectangular cross section. So first what we are doing, using this puller at intermediate places. For suppose this one is a round piece, using that pullering hammer, puller forces are applied on the top surface. Then what happens, initially the round shape is length will be increased. So when you applying this kind of hammer set along its length, if you apply like that, its thickness is reduced, diameter is reduced, so some initial shape will be formed. So initial flat shape will be formed. After that one, after using this puller, we are going for this kind of flatter. if you place over that one and apply the hammer blows, that following marks which are obtained using this one, that following marks will be removed and the top surface and bottom surface will become flat. That is the application of fuller used in the forging. Next one is punches. It is used already, these punches you have we discussed it in the that is fitting process also. It is used in the forging shop for making of holes in a metal part when it is at forging heat. To make holes in the workpiece when the metal is heated above recrystallized temperature, then manually we cannot hold this one. With the help of that tongs, you have to place this one at a heated workpiece, and if you apply the hammer blows at the top, you can make holes on the heated workpiece. This is one kind of forging process. Next one is rivet header. So it is used in the forging shop for producing rivet heads on the parts. So rivets, we know that rivet is having that is the head in the semi-sphere shape. Semi-sphere shape. So where the this rivet header held like this. So it is having a hole. See this one where we have a cavity. This cavity is a hole in the shape of sphere, round shape. So on the for suppose this is a rivet. We want to make a rivet head at top. Then we take this rivet header, place it over that one. If you apply the hammer blow, at the top of this one, the shape is converted into rivet head as shown using this rivet header. So this is the application of rivet header. Next, this is sigils. Sigils are used for cutting the metals and for nicking prior to the breaking, prior to baking. So hard sigil. So these sigils in carpentry also we have seen that is used to cut. Similarly, when you want to cut the metal bar, okay, where we have a metal bar. So first using this one, this sigil head, we apply the hammer blows. One, see here, nicking prior to baking. After that, easily we can bend. For that one, these kind of sigils are used. Now hand hammers. So basic two things in the hot working process. One is heating and applying the hammer blows. Where we have different types of hammer blows. So different types of hammer. See this one, cross pin hammer, straight pin hammer, ball pin hammer. So double faced, set top and bottom. So here say single pin. This is see straight pin hammer. So here we have the cross pin hammer, like that. Different types of hammers we use in the hot working process. This is forging process, and this one is anvil. It acts as support for blacksmithy. Blacksmithy means forging process. Blacksmith is work during the hammering. So in the starting itself, I told you heated workpiece is placed on the anvil. This is the anvil. So anvil is a ferrous alloy. Say this one, it is having holes, round holes, square holes, rectangular holes where we have. Say this one is one kind of projection we have on this anvil. So that heated workpiece, if you want to make into round shape, so with the help of this one, that heated workpiece is placed here, and applying the hammer blows, we can bend the straight workpiece into required round shape. So just like a ring, if you want to bend that one, we are using this one to make the flat surfaces. The top surface of this one is used. This is anvil, which acts as support for the all blacksmithy operations during the hammering process. Next, we see this other equipment. So directly we will not use these equipment, but in blacksmithy use. One is shovel. It is used to place coal or coke in the furnace during the heating the workpiece above it recrystallized temperature. For handling of coke and coal, we are using the shovel. It is used to set coal pieces in the furnace and remove the ash for the furnace. So that is the application of the shovel. Next we see the poker. It is used for removing the clinker from the furnace and to lose the compact coal pieces in a furnace. That is use of this poker. Next one is rake. It is used to put the coal pieces in tires. These are the other tools used in the furnace while we are heating the workpiece. Now, heating device. So, this is a furnace. See this one. This is the top one. This is chimney, water tank at here. This one is tire. This one is head. So here coal is placed, and through this one we can supply the air to that is to ignite that one. While the workpiece is heated, we have to apply the compressed air that will be supplied through this one. Forgeable, this is forgeable metals are heated either in the hearth or in a furnace. Say heating the forge furnace are built rise temperature up to 1300 degrees, 1350 degrees of Celsius in their working chambers. Heating furnace, this heating furnace consists of parts including fire blocks, working chamber, chimney at the top you have flues. This one is recuperator or uh, regenerator and various other auxiliary arrangements we have in the heating furnace. So in this furnace, the workpieces are heated above its recrystallization temperature. Thank you.